Okay, so welcome to class today. We are going to be working in section 2.5 today. We're going to be doing multiplication of matrices. So if you look at this first box, it's telling us that we're going to be multiplying rows by columns. And the way we do that, if you look right here, maybe I'll just show you by an example, but we take each row times a column. Okay, I was getting some feedback there. I think this is better. So we multiply each row times a column, and I'll show you how we do that. I think it's probably easier just to show by example here. So looking at example 1, I need to multiply R times C. So if you look at this, please notice that on the left side I have an R, and on the right side I have a C. You have to multiply in the order that you see it. Now let's look at the dimensions of R. R is 1 row and 3 columns. That's a 1 by 3. C has 3 rows and 1 column. So remember the dimensions, you put the rows first and the columns second. Now, the middle numbers in the order that I see them, R on the left side, C on the right side, the middle numbers have to be the same in order to multiply them together. And the outside dimensions will actually be the dimensions of your answer. So I should be getting a 1 by 1 matrix for my answer. Okay, so here is how I'm going to do this. I'm going to take matrix R and actually write it down, 1, 5, 3. It's a row matrix. And the column matrix is 2, -1, 4. To multiply these together, I take the first element in the row and multiply it times the first element in the column. Now sometimes that's kind of hard to kind of match up. So what I'll do is I'll put the 1, the 5, and the 3. It's kind of like I'll take that first row and put it vertically, rotate it vertically or like 90 degrees and match up so I can see I'm going to be multiplying 2 times 1, and then I'm going to be multiplying -1 times 5, and then I'm going to be multiplying 4 times 2. So I take the 2 times the 1, the 5 times the -1, and the 3 times the 4. And what I do with those is I add them together. So basically I'm getting a 2 plus -5 plus 8 to get a final answer of that's not right. 4 times, that's not okay. I'm sorry. I was having trouble because I'm like going, that's a 4 times 2, but I think it's supposed to be 4 times 3. Did you guys already catch that mistake? Right here, that is a 3, and I couldn't read my own writing. So that's not an 8 there, that was a 12. There we go. Now I'm getting the right answer. I wasn't getting the right answer. So I get a final answer of 9. Now remember that's supposed to be a 1 by 1 matrix. So the way we write that, it's just a 9 in brackets there. So there it is. Now I like to show something besides just a 1 by 1 matrix because sometimes that's confusing. So let's look on to example 2. Number 2, I have a 1, -2, 3, and I'm going to multiply it times that matrix 0, 1, 1, 2, 2, 3. So let's do the dimensions first. I always check dimensions. Here I get a 1 row, 3 columns. This second matrix I have 3 rows, 2 columns. Do the middle numbers match up? And the answer is yes. And the dimensions of my answer will be a 1 by 2. That means 1 row, 2 columns. So it'll look like that. Okay, so here's how I kind of go through and multiply this out. I'm going to take the 1, -2, 3 and really slightly, real small here, put a 1, -2, and 3. I'm just kind of putting it right by that first column. So I'm taking 0 times 1 and I get a 0. 1 times -2, I get a -2. And 2 times 3, I get a 6. And I add those 3 together. And that will actually be my answer for that first row, first column. Okay, then I erase those. Okay, now I'm ready to do the second row. I mean the first row times the second column. So again, real small, I'm going to put my 1 and then my -2 and my 3. And again, that's just my visual, so I can see that I'm multiplying 1 times 1 to get a 1, 2 times -2 to get a -4, and 3 times 3 to get a 9. Okay? Now, again, that's not a step I would probably show, but it's helpful, I think. So I can do this mentally. 6 minus 2 is a 4. 10 minus 4, I get a 6. If you want to go straight to that matrix, that's okay. So I just wanted to kind of show my work since I'm doing a video here. Okay, let's do the next one, a little bit bigger. I have example 3, everybody with me? I'm going to look at my dimensions of the matrix on the left. I have 2 rows and I have 3 columns, so that's a 2 by 3 matrix. On the right side, I have 3 rows and 2 columns. So again, I check, are the middle numbers the same? Yes. And this one will be a 2 by 2 matrix. Okay, so what does a 2 by 2 matrix look like? It's going to be kind of like boom, 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 boom. There we go. 4 spots we're going to fill in. Okay, so again, I'm going to take my pencil. Make sure you use a pencil for this because it's very helpful. I'm going to take this row right here and I'm going to rotate it times that first column. So I have a 1, -2, and a 3 there. And again, I'm writing so small it's hard for me to see my numbers. So I take 0 times 1 and I get 0. 2 times 1, I think that's supposed to be a -2. -2 times 1 is -2, and 3 times 2 I get a 6. Okay? So when and again, this could be the step that you skip if you want to do this all mentally. So if I take 6 minus 2, I get my 4 for that spot. Okay, so I'm going to erase it now. I'm still using that first row. Now I'm going to move it down for the second column. I'm going to put a 1 here. And then I'm going to put a -2, and then I'm going to put a 3 and multiply. -2 times 1, I'm going to get a -2. 0 times -2, 0. 3 times 4, 12. So I get 12 minus 2 for that spot. I get 10. Okay, so let me go back. And I've used up this first row, so I can mark that out. Now I'm ready to use the second row. I'm going to do the same thing. I'm going to take the 4 and put it with the first column, the 0 and the 6. Line those up, and I'm going to be multiplying 4 times 0 to get a 0. 0 times 1 to get a 0. 6 times 2 to get 12 for a final answer there of 12. Okay, now I'm going to erase that, and I'm going to move down to the second column. So I'm going to take 4 times the -2, so I'm going to put it right there. 0 times a 0, 6 times a 4. Again, that's just my little way of going through and just making sure I'm multiplying the correct numbers together. So I get a -8 plus 0 plus 24, and I add those together, and I'm getting 16. So this is my answer right here. And you can go from here straight to the answer. You don't need to put that little matrix where you're showing what you're adding together. That's just for me to kind of help you see where I'm getting those numbers. Next page. Let's just kind of add to that. Okay, working with example 4, I'm going to once again start with my dimensions. I get here, this is 2 rows, 3 columns. This second matrix is 3 rows, 3 columns. Are my middle numbers the same? Yes, they are. So my dimensions of my answer should be a 2 by 3, 2 rows, 3 columns. Okay, so let's see if we can do it without putting that intermediate matrix in. So I'm going to take, first of all, 1, -2, 3, and I'm going to take that and multiply it by each one of the columns that you see in the second matrix. So I'm going to start by putting my 1, -2, 3. 1 times -1 is -1. The second one I get a -2 and a 0. So what's -1 and -2? I get a -3. You know, I changed my mind. Since I'm doing a video, I'm going to put that middle step in because I get a -1 -2 plus 0. Final answer is -3. Maybe that'll help. Okay. So then I'm going to erase that, move it down, and I'm going to put a 1, -2, and 3. So I multiply those numbers together, I get a 1. 1 times 2 is 2. I should multiply together, I guess. -6 and +12. So I get 6 plus 2. I'm getting 8 for that next one. Okay, so let's erase. Now I'm going to move it down. I'm going to put a 1 here, a -2, and a 3. So 1 times 1 is 1, plus 0, plus 3, to get a total answer of 4. Okay, so I am all done with that first row. So I'm going to erase, and actually I'm going to mark out that first row because I'm done with it. Now I'm ready to take the second row and I'm going to multiply it by each one of those columns in the second matrix. So I'm going to take 4, 0, 6, and those are the numbers I'm going to be adding in here. 4, 0, 6. So 4 times -1 is -4, 0 times 1 is 0, and 6 times 0 is 0. So I just get a -4 for that. Okay, so I'm going to erase, move the 4, 0, 6 down. 4, 0, 6. So it looks like I'm going to get an 8 plus 0 plus 24. 8 plus 24 is 32. And move it down again. So I'm going to put a 4, 0, 6. 4 times 1 is 4, plus 0, plus 6, to get an answer of 10. Again, the top matrix is not needed if you can keep track of all your numbers mentally and then just keep adding as you're moving down the column here. You can do that. Okay, so there is our final answer. Let me circle it. That right here is the matrix I need to have. Okay, so properties of matrix multiplication. Number 1, multiplication of matrices is possible only if the number of columns of the matrix on the left equal the number of rows of the matrix on the right. Now, what that is stating is what I was having you check right here. As long as those are equal, you can perform matrix multiplication. Matrix multiplication is not commutative. A times B will not be the same as B times A. So it's really important that you write down the matrices in the order that they tell you to. Matrix multiplication is associative. That means I can do different groupings as long as I keep them in the same order. And it is perfectly okay in matrix multiplication. And a distributed property for matrices states that A times quantity B plus C is the same as A times B plus A times C. Okay, so those are just some properties we'll probably work with in the homework. And then looking at the identity matrix. Okay, now this is something that you have to have memorized. What is an identity matrix? Well, basically it's going to be it has to be a square matrix. And what you will see here is if I have let's look at the one at the end, a 4 by 4 matrix, I4, I with the subscript of 4 means that I have a 4 by 4 matrix and I have a diagonal of 1s going from the upper left to the lower right. See the 3 by 3 matrix right here? Diagonal of 1s from the upper left to the lower right. Everything else is zeros. Same thing with the I sub 2. Remember that subscript is just going to be telling you what the dimensions are of that matrix. Now, the identity matrix, basically it's like multiplying by 1. But in the matrix world, we can't just say multiply by 1. We have to say multiply by another matrix, so that's why we call it the identity matrix. If A is a square matrix of dimensions n by n, then A times I is the same as I times A, which is the same as A. So that matrix multiplication is commutative with the identity matrix, and that will be equal to A, which is what you started with. One thing I need to point out about the commutative property right here is there will be some special matrices where you can switch them. A times B will be equal to B times A, but as a whole for matrix multiplication, it is not commutative because it's really needing to hold for all cases, and it really doesn't. Okay, so this last example here is that I'm just going to work with you on showing you that if you take a matrix 3, -1, 4, 2 and multiply it by an identity matrix, we're going to see that we get the same thing. Okay, so I'm going to once again check my dimensions. This is a 2 by 2 matrix, and this is a 2 by 2 matrix. So my middle numbers match. My outside numbers tell me the dimensions of that matrix. So I know I'm going to have a 2 by 2 matrix. 1, 2, 3, 4. Okay. So, like what we did for the other ones, I'm going to take the 3, -1, and I'm going to multiply that by the first column, 3, -1. So I get a 3 plus 0. Then I'm going to erase that and move it down. And I multiply that by a 3, the 0 times 3, and multiply the 1 times the -1. So I get a 0 minus 1. So let's just kind of match up what I have so far in my answer. 3 plus 0 is 3, and that 0 minus 1 is -1. So that's what I have so far. I'm going to now erase because I'm done with that first row, so I can mark that out. Now I'm going to take 4, 2, and multiply that by the first column, putting a 4 there and a 2 there. I get 4 plus 0, which we all know is 4. Erase that and move it down. And I'm going to put my 4 here and my 2 there. So I get a 0 plus 2 to get a 2. Now look and see what we started with. Did we start with the same thing that we ended up with? Look right there. 3, -1, 4, 2. Yes, we did. So multiplying through by a 2 by 2 identity matrix, I produced the same matrix that I started with. Okay, that is all for 2.5 notes on multiplication of matrices. You have a great day.